Welcome to 6.1 Inverse Circular Functions. We are going to start with a quick introduction of the inverse of tangent. So I have graphed one period of tangent, so y equals tangent x. Remember, we get asymptotes at negative pi over 2 and pi over 2, and it's increasing going through 0, 0. Now we get additional replications of our tangent if we keep going. So we'd have the same curve over and over again because it's periodic with period pi. In order for this to be one-to-one, we're just going to restrict the domain to this natural interval negative pi over 2 to pi over 2. So notice this is the same as the sine inverse. So we have y equals tangent inverse of x, or y equals arctan of x. This is just the same as tangent y equals x. The angle whose tangent is x, or the arc whose tangent is x. Either way, we could write that as tangent of y equals x. So instead of having vertical asymptotes at negative pi over 2 and pi over 2, we're going to end up with horizontal asymptotes at negative pi over 2 and pi over 2 in the inverse. Because the inverse will be a reflection over the line y equals x, it will still be increasing and going through the origin at 0, 0. So this is a graph of the entire function y equals tangent inverse of x. So we have our domain is all real numbers because our range of tangent goes from negative infinity to infinity, and our range is going to be restricted from negative pi over 2 to pi over 2, just as we restricted the domain of the original function from negative pi over 2 to pi over 2. Now, the three remaining trigonometric functions also have inverses. So we have y equals cosecant inverse of x, y equals secant inverse of x, and y equals cotangent inverse of x. The graphs of these are sketched quickly in the notes. However, we're not going to be focusing much on the graphs of any of the inverse functions. What is very important to know about all 6 of the inverse functions is what are the ranges? What are the possible values you can get from these inverse functions? And they fall into 2 categories. The 2 possible ranges for all of our inverse functions are either going to be negative pi over 2 to pi over 2 or 0 to pi. I like to think of the negative pi over 2 to pi over 2 as the sine group. We have y equals sine inverse of x. We just found that tangent inverse of x also has this range. And there's one more, and it's the reciprocal of the sine function, which is the cosecant. So y equals cosecant inverse of x also has a range of negative pi over 2 to pi over 2. Now, I like to think of the 0 to pi group as the cosine group. So we have y equals cosine inverse of x is our leader. The reciprocal of cosine is secant, so y equals secant inverse of x also has this. And now, y equals cotangent inverse is also in this group. For cotangent, one thing I like to think of is the y equals cotangent x, the regular function that we're more familiar with. Our asymptotes were at 0 and pi, so then we got that full range here in between 0 and pi. So that's graphically why it makes sense that the cotangent inverse is going to have a range of 0 to pi. For memorization purposes, I like to think of tangent and cotangent follow whoever's in the numerator. So since tangent is sine over cosine, it's going to go in the sine group. And since cotangent is cosine over sine, it's going to go in the cosine group. But that's just a way to memorize it. This information right here is the most important aspect of the inverse functions. Knowing that inverse functions will only give you one answer, and that these three inverses have values in between negative pi over 2 and pi over 2, whereas these three inverses have values between 0 and pi. Practice problem. Write y equals secant inverse of x using inverse cosine. So the first thing we need to do is we need to get this into a regular secant so that we can use our reciprocal identities. So secant y equals x. Remember, this means find the angle whose secant is x. So secant y equals x. Now we can use the reciprocal identity. Since we know secant y equals x, we can find the cosine of y by flipping x, or getting 1 over x. And that's because these are reciprocal functions. Now we're ready for the cosine inverse. Now we have y equals cosine inverse of this value, which is 1 over x. So you are welcome to memorize anytime you're trying to find an inverse of a reciprocal function. You could always just put in the inverse of the regular function and you input 1 over the value. However, I like to just write this out. It's not a whole lot of work, and it makes sure that I'm very careful about when I flip and where I put my 1 over. Y equals arctan of rad 3. So notice in the directions, they specified that we should give our answer in degrees. If it's not specified, you should always give your answer to inverse problems in radians. So again, because arctan is a function, I will only expect one answer. I'm looking for tangent of y equals rad 3. So what angle has a tangent of rad 3? Since we see that square root of 3, we're thinking it's going to be a 30, 60, 90. Remembering that tangent is in the sine group, or we're going to have a value negative pi over 2 to pi over 2. Since it's positive, we're going to be in quadrant 1. So whether you're using the unit circle or you're using triangles, you sometimes have to guess and check to figure out how on earth am I going to get the tangent to be rad 3. One way to think of it, in triangles, my tangent is y over x, and that's going to be equal to rad 3. So I could think of y being rad 3 and x being 1. So that's going to end up being a 60 degree. So y equals 60 degrees. Another method is, once you find that it's going to be a 30 or a 60, you just try one and you use either your triangles, your unit circle, or tables, and you just check. And if it's not 30 degrees, then it's going to be 60 degrees or vice versa. So my answer is y equals 60 degrees. Notice now the negative pi over 2 to pi over 2 doesn't make as much sense because I'm in degrees. So really these ones would have been negative 90 degrees to 90 degrees. B, y equals cosecant inverse of negative rad 2. Converting this, I can write cosecant of y equals negative rad 2. I could work with this, or I can convert this into sine. So sine of y equals 1 over negative rad 2. Rationalizing, I get sine of y equals negative rad 2 over 2. So now that's a sine value for a 45. But let's be careful, because cosecant inverse and sine inverse are negative pi over 2 to pi over 2, or in degrees, negative 90 degrees to 90 degrees. So if I have the sine is a negative and we realized our reference angle is 45, now you have to be careful on how you're going to express this. I can't just do 360 minus 45 to get 315 degrees, because 315 degrees is not in negative 90 degrees to 90 degrees. So the way I have to list this angle is y equals negative 45 degrees. And that's my final answer. Just FYI, in radians, My answer here would have been pi over 3, or my answer here would have been negative pi over 4. I hope you enjoyed this video. See you next time.